Hi friends, welcome back to our channel Physics Tutorial. Today we are going to continue the textbook exercises of 9th standard Gravitation. Can we move to the video? Till question number 8 we have discussed in the last class. Now we can start with question number 9. So here the question is, page number is 144 in your NCERT textbook, and the question is, what do we call the gravitational force between Earth and an object? What we will call the gravitational force between the Earth and an object. ഒരു ഒബ്ജക്റ്റിനും എർത്തിനും ഇടയ്ക്കുണ്ടാവുന്ന gravitational force നെ നമ്മൾ വിളിക്കുന്ന പേരെന്താണ്? What we can call എന്നുള്ളതാണ് question. So what is the force between an object and Earth? Yes, that is weight of the body, right? Our weight is calculated by using the equation W is equal to m into g. That means the force with which the earth is attracting us towards the center, that is the weight of our body. So W is equal to mg is the weight of the body. So we can say that the gravitational force between earth and an object is called weight of that object, and that is calculated by using the equation W is equal to m into g. Okay, then we can move to the 10th question. The question is, Amit buys few grams of gold at the poles as per the instruction of one of his friends. He hands over the same when he meets him at the equator. Will the friend agree with the weight of the gold? Then, if not, why? That is the question. A hint is given here. The value of acceleration due to gravity is greater at poles and lesser at the equator. So that hint is already given to you. So here in the question, Amit buys a few grams of gold from the poles. And from poles he buys some gold, and the same amount of gold he hands over to his friend from the equator. So will he agree? That means what will be the weight in both the cases, that is in equator and poles. A hint is given as in poles the value of g is greater, and in equator the value of g is lesser than poles. Okay, so what will be the answer? So how we can find the weight of the body in Earth? That is how we will find the weight. That is W is equal to, yes, m into g. Right. Then mass of the body is m, and g is, that is W is equal to mg is the weight. W is equal to m into g. Here m is the mass and g is the acceleration due to gravity. So the weight varies according to the value of acceleration due to gravity. അതായത് ജിയുടെ വാല്യൂ മാറുന്നതിനനുസരിച്ചിട്ട് എന്ത് സംഭവിക്കുന്നുണ്ട്? യെസ്, വെയിറ്റിന് വ്യത്യാസം വരുന്നുണ്ട്. അപ്പോ പോൾസിലായിരിക്കുന്ന സമയത്തും ഇക്വേറ്ററിലായിരിക്കുന്ന സമയത്തും ജിയുടെ വാല്യൂവിന് ഒരു പ്രത്യേകത ഉണ്ട്. അതായത് പോൾസിൽ എങ്ങനെയായിരിക്കും? ജി ഗ്രേറ്റർ ആണ്, ജിയുടെ വാല്യൂ കൂടുതലാണ്. And in the case of equator, what will happen? G will be decreased. So what will happen? Yes, ഇവിടെ നമുക്കറിയാം ഷേപ്പ് ഓഫ് ദ എർത്ത് എന്ന് പറയുന്നത് എന്തല്ല, ഒരു പെർഫെക്റ്റ് സ്ഫിയർ അല്ല. സോ ദാറ്റ് ഈസ് വൈ ദ പോൾസ് ആൻഡ് ദ റേഡിയസ് ഓഫ് പോൾസ് ആൻഡ് ഇക്വേറ്റർ ആർ ഡിഫറെന്റ്, അല്ലെ? സോ റേഡിയസ് ഓഫ് എർത്ത് ഇൻക്രീസസ് ഫ്രം പോൾസ് ടു ഇക്വേറ്റർ. നമുക്ക് എർത്തിന്റെ ഷേപ്പ് അറിയാം. സോ ഫ്രം പോൾസ് ടു ഇക്വേറ്റർ what will happen when it moves? What will happen? Suppose this is the shape of earth. It is not exact sphere. Here we can see. So this is the pole and this is equator, right? Here we can see that radius is lesser than that of equator. So here if radius is lesser means what will happen? G becomes greater at poles, and here at poles the value of G will be more. Okay, this is pole. So what will happen to weight? Weight will be more in poles than equator. Here in equator what happens? The radius is high, that is why the value of acceleration due to gravity is less. So where the weight will be more, in poles the weight will be more, but when we reaches the equator, what will happen? The weight will be less. So will he agree with that? No, it is not possible to agree, right? Therefore gold on the equator weighs less than at the poles, hence Amit's friend will not agree with the weight of the gold. So that hint is already given to you, then according to that we can answer the question. So here what happens? At the equator the gold will be having lesser value. That means weight will be less than that of the pole. So he will not agree. Clear? Now we can move to the 11th question. The question is, why will a sheet of paper fall slower than one that is crumbled into a ball? അതായത് why a sheet of paper falls slower than one that is crumbled into a ball? അതായത് ഒരു same sheet of paper we are taking and one we are crumbling into a ball and the other one as a sheet we are putting down. So both are falling together, but why that paper sheet of paper is falling slower എന്നുള്ളതാണ്. എന്തുകൊണ്ടാണ് പ്ലെയിൻ ഷീറ്റ് ഓഫ് പേപ്പർ സ്ലോവർ ആയിട്ട് താഴെ വീഴുന്നത്? ക്രംബിൾ ചെയ്ത് ബോൾ ആക്കിയത് എന്ത് ചെയ്യും? ഫാസ്റ്റർ ആയിട്ട് താഴെ വീഴും. അതിന്റെ റീസൺ എന്താണെന്നുള്ളതാണ് ചോദിച്ചിരിക്കുന്നത്. സോ in which case the surface area will be lesser? Yes, in the case of a ball, what will happen? The surface area of ball will be lesser than the surface area of sheet of paper. So as the surface area increases, the upward force exerted by the air will be more. Okay, so in the case of plain sheet of paper, what will happen? The air resistance or the upward force in air will be more than that of the crumbled sheet of paper. Okay, so what will happen? That as the resistance is more from downwards means the opposite force is coming, no? So that means the sheet of paper will be falling slowly than that of the crumbled paper. So that example will be very familiar to you, right? So that is all about the sheet of paper, how it falls slowly or faster. Okay, and now we can move to the next question, 12th question. That is, the gravitational force on the surface of moon is only 1/6 as strong as gravitational force on earth. That fact we have already known, right? Gravitational force on the surface of the moon is 1/6 of that of the gravitational force of earth. Then what is the weight in Newton of a 10 kilogram object on the moon and on the earth? So a body is having 10 kilogram weight, and what will be its weight in earth and in moon? That is our question. So here we have to calculate the weight of that 10 kilogram object in earth and in moon. So how we can calculate? Here we know that the weight of an object on moon is equal to 1/6 weight of that of earth. Okay, so here the object has having 10 kilogram weight. Okay, that mass is given as 10 kilogram. Then what will be the weight of the object in earth? Mass is 10 kilogram means weight is W is equal to M into G. So M is 10 into G is 9.8, so that will be 98 Newton. So that is the weight of the object on earth, and now we have to find the weight of the object on moon, the same body we are taking. So 10 kilogram object we are taking, then here the weight on earth we have already calculated. Then we know that that will be 1/6 of that of the earth, right? In moon the 1/6 of the weight of earth will be there. അതായത് എർത്തിൽ ഉണ്ടാവുന്നതിന്റെ 1/6 മാത്രം വെയിറ്റ് ആണ് എവിടെ ഉണ്ടാവുന്നത്? മൂണിൽ ഉണ്ടാവുന്നത്. So here we can calculate 1/6 into 98. So that will be 16.3 Newton. So like that we can calculate. So here not mass, weight is asked. Okay, so weight ആയതുകൊണ്ടാണ് W is equal to M into G calculate ചെയ്യുന്നത്. Don't forget to calculate mg. Okay, so that we are getting as 98 Newton, and 1/6 of that weight is equal to the weight on the moon, that is 16.3 Newton. Now we have the 13th question. The question is, a ball is thrown vertically upwards with a velocity of 49 meters per second. Calculate the maximum height to which it rises. And the second question is the time taken to return to the surface of earth. So here the two questions are given. The first case, a ball thrown vertically upwards and the initial velocity is given, and at the top what will be the velocity? When it reaches at the maximum height, the value of velocity will be 0. So the final velocity will be 0, and first of all we have to calculate the maximum height it reached, and then we have to calculate the total time taken by the ball to reach to the ground. So these two questions we have to answer. So first of all we can look into the given data. What are the things given here? So the initial velocity is given as 49 meter per second. That is u is given as 49 meter per second, and what will be the final velocity? That will be 0. And what about the acceleration due to gravity? Here the object is having free fall, right? That means the acceleration will be acceleration due to gravity, that is 9.8 meter per second square. And one more thing that you have to remember is we are putting that the object is moving upwards. That means if we throw it vertically upwards means the acceleration due to gravity is in the upward direction, so that should be taken as negative. Actually the acceleration is to the downwards, right? It is in the downward direction, but here we throw it upwards. That means the g value should be taken as negative. And which equation can be used to find the maximum height? So here we have three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, then v square is equal to u square plus 2as. Okay, so out of these three equations, which can be used to find the maximum height? So here which equation is having s value or displacement? Here in these two equations only we have, right? The time is not given here, so which can be used? Here we have v, u, and here instead of a we are using g. Okay, so these three quantities we have only s we have to find. That means the third equation can be used. And here we are using free fall, means we can substitute g instead of a and h instead of s. അതായത് എക്ക് പകരം എന്ത് കൊടുക്കാം? ആക്സിലറേഷൻ ഡ്യൂ ടു ഗ്രാവിറ്റി കൊടുക്കാം. ദെൻ ഹൈറ്റിന് പകരം, അതായത് ഡിസ്പ്ലേസ്മെന്റിന് പകരം നമുക്ക് മാക്സിമം ഹൈറ്റ് എച്ച് ഇവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. സോ ദ ഇക്വേഷൻ ബിക്കംസ് ദ തേർഡ് ഇക്വേഷൻ, ദാറ്റ് ഈസ് v സ്ക്വയർ ഇസ് ഈക്വൽ ടു u സ്ക്വയർ മൈനസ് 2gh. Now we can substitute the values. Here we have v is equal to 0, u is equal to 49 meter per second, g is equal to 9.8 meter per second square. So what will be the value? Here h is the maximum height attained by the ball. So when we substitute, what we will get? V square means 0 square minus, here we have, yes, v square minus u square we are writing here. So v square minus u square is equal to 2gh. Like that also we can write. So here we can write like that. V square minus u square is equal to 2gh. That is 0 square minus 49 square is equal to 2 into g is minus 9.8 into h. So in such a case we have to take the value of g as negative. If it was coming down means we can take it, yes, positive. So here what will happen? H we have to find, right? So h will be equal to 49 into 49 by 2 into 49 into 9.8. Right, so that will be 122.5. So that is the height attained by the ball. So height we can calculate as 122.5. Okay, now we have the next question. That means the total time taken by the ball to return to the ground. So that we have to calculate. So here which equation can be used? Here time we have to calculate, right? So this equation is not possible. Here there is no time. And what about first equation? Here we have v, u, a. Only t we have to find, right? So we can use the first equation. So v is equal to u plus gt. So what we will get? V is 0. Final velocity is 0. Then u is 49 plus g into t. So t into minus 9.8. So what we will get? 9.8 t is equal to 49, or t is equal to 49 by 9.8. That is 5 seconds. So here the time for in one direction we are getting as 5 seconds. So here when we calculate the total time taken by the ball to return to the ground, to the earth's surface, means here the total time of ascent is equal to time of descent. So how we can find the total time? 5 plus 5. Okay, so in one side it is taking 5 seconds, means in opposite side for descent also it will be taking 5 seconds. So total time means 5 plus 5, that is equal to 10 seconds. So like that we can calculate the total time taken by the ball to return to the surface of the earth. Clear? Now we can move to the 14th question. The question is, a stone is released from the top of a tower of height 19.6 meter and calculate the final velocity just before touching the ground. So here we have an object, that is a stone, which is released from a height of a tower. Tower has 19.6 meter height, and we have to find the final velocity. So how we can find the final velocity? So first of all, the given quantities we can write. The initial velocity was 0, right? U is equal to 0 and height of the tower is h or s. So that is 19.6 meter and acceleration due to gravity is 9.8 meter per second square. Then here is stone is released from the top of a tower. Okay. And we have to find final velocity. So u, then h is there, then g is already there, then we have to find v, final velocity. So which equation can be used? ഇവിടെ നമുക്ക് 3 equations of motions ഒന്ന് എഴുതി നോക്കാം. v is equal to u plus at, s is equal to ut plus half ad square, and v square minus u square is equal to 2as. അതിൽ ഏത് equation ആണ് യൂസ് ചെയ്യേണ്ടത്? Here we have to calculate h or s. ഏതാണ്? ഈ രണ്ട് ഇക്വേഷൻസിൽ മാത്രമാണ് എസ് ഉള്ളത് അല്ലെ. പിന്നെ ഗിവൺ ക്വാണ്ടിറ്റീസ് ഏതൊക്കെയാണ്? യു, ജി. അതായത് യു ഉണ്ട്, ഇൻസ്റ്റെഡ് ഓഫ് എ വി ക്യാൻ റൈറ്റ് ജി ബിക്കോസ് ദിസ് ഇസ് എ ഫ്രീ ഫോൾ. ഫ്രീ ഫോൾ ആയതുകൊണ്ട് എന്ത് ചെയ്യാം, ഇവിടെ നമുക്ക് ജി എന്ന് എഴുതാം. Then this equation can be used. Last equation v square minus u square is equal to 2gh യൂസ് ചെയ്യാം. So substitute ചെയ്യുമ്പോൾ എന്ത് വരും? v is, yes, we have to find v. So v square minus u square, so 0 square, that is equal to 2 into g is 9.8 into 19.6. So v square is equal to 19.6 the whole square, because 2 into 9.8 is again 19.6. So v square is equal to 19.6 the whole square, then v will be equal to 19.6 meter per second. So that is the final velocity of the stone. v is equal to 19.6 meter per second. ഇനി അടുത്ത ക്വസ്റ്റ്യനിലേക്ക് പോവാം. 15th question. A stone is thrown upwards with an initial velocity of 40 meter per second. Taking g is equal to 10 meter per second square, find the maximum height reached by the object, അതായത് or the maximum height reached by the stone, and here we have to calculate the displacement and total distance covered by the stone also. So first of all, the given quantities we can write. Initial velocity u is given as 40 meter per second. Final velocity means at the maximum height we know that the object will not be moving. Maximum height എത്തുന്ന സമയത്ത് object എന്തിലായിരിക്കും? റെസ്റ്റിലായിരിക്കും. So the velocity, final velocity will be equal to 0. Then s is equal to h ആണ്. Then g is equal to minus 10 meter per second square, because the object is, that means the stone is thrown vertically upwards ആണ്. upwards ആയതുകൊണ്ട് തന്നെ acceleration due to gravity will be minus 10. Okay, ഇവിടെ minus 10 ആയിട്ട് എടുക്കാൻ നമുക്ക് പറഞ്ഞിട്ടുണ്ട്, otherwise we have to take 9.8. Then we can substitute. ഏത് equation യൂസ് ചെയ്യണം ഇവിടെ? v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. ഇതിൽ ഏത് equation യൂസ് ചെയ്യാം? Yes, again v square minus u square is equal to 2as. So ഇവിടെ a ക്ക് പകരം g എന്ന് കൊടുക്കാം, s ന് പകരം h എന്ന് കൊടുക്കാം. So what we will get? v square minus u square is equal to 2gh എന്ന് കിട്ടും. സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താലോ? So v എന്ന് പറയുന്നത് എത്രയാണ്? 0 ആണ്. ഫൈനൽ വെലോസിറ്റി 0 ആണ്. So 0 minus 40 square is equal to 2 into minus 10 into h എന്ന് വരും. So h will be equal to 40 into 40 by 20. So that is 80 meter. അപ്പോൾ 80 meter ആണ് ഹൈറ്റ് വരുന്നത്. സോ മാക്സിമം ഹൈറ്റ് എന്ന് പറയുന്നത് എത്രയാണ്? 80 മീറ്റർ ആണ്. ഇനി അടുത്ത ക്വസ്റ്റ്യൻ എന്താ പറഞ്ഞിട്ടുള്ളത്? ടോട്ടൽ ഡിസ്റ്റൻസ് ട്രാവൽ ബൈ ദ സ്റ്റോൺ ആണ്. ടോട്ടൽ ഡിസ്റ്റൻസ് എത്രയാണ് ട്രാവൽ ചെയ്യുന്നത്? 80 സെന്റിമീറ്റർ, അതായത് 80 മീറ്റർ മുകളിലേക്ക് പോയിട്ടുണ്ടെങ്കിൽ എന്ത് ചെയ്യുന്നുണ്ടാവും? അത്രയും ഡിസ്റ്റൻസ് അത് താഴത്തേക്ക് മൂവ് ചെയ്യുന്നുണ്ട്. സോ ദാറ്റ് the total distance travel will be 80 plus 80, that is 160 meter. And what about net displacement? Yes, അത് മുകളിലേക്ക് പോയി താഴത്തേക്ക് തന്നെ വന്നു കഴിഞ്ഞാൽ എന്താണ്? അത് സെയിം പ്ലേസ് തന്നെയാണ്. So the displacement will be 80 minus 80, so the total will be 0. So displacement is 0 and total distance is 160 meter. So this is all about question number 15. Now we have 16th question. The question is, calculate the force of gravitation between the earth and sun. Here the mass of the sun is given and mass of earth is given. The mass of earth is 6 into 10 raised to 24 kilogram and mass of sun is 2 into 10 raised to 30 kilogram. And here we have to calculate the force of gravitation between the sun and Mars. And also it is given that the average distance between sun and earth is 1.5 into 10 raised to 11 meter. So how we can calculate the force of gravitation between Mars sun and earth. So how we can calculate? Yes, by using universal law of gravitation, we can calculate the gravitation between these two, that is earth and sun. So which equation can be used? F is equal to G into m by r square. So here we have mass of sun and mass of earth divided by r is the distance, average distance between sun and earth. So we can substitute the value. So G is the universal gravitational constant, that is 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. So that value we can substitute here. So what we will get? F is equal to 6.7 into 10 raised to minus 11, that is G into mass of sun, that is 2 into 10 raised to 30 into mass of earth, that is 6 into 10 raised to 24 whole divided by r. The distance is the average distance between sun and earth, that is 1.5 into 10 raised to 11 the whole square. So when we calculate, the answer is found to be 3.57 into 10 raised to 22 Newton. So you can calculate that to get this value, and hope it is clear to you. Now we can conclude the video. If you like the video, please like, share and subscribe. Thanks for watching.